Okay, so just if you look just at the averages, it seems like those who drank the energy drink read faster. I mean, they did. But the question was it coincidental? Were the people that were put into this group already faster readers? So this is where our simulation is going to help us determine if it's coincidental or if that's a significant difference. Ava thinks drinking energy drinks makes students read faster. Using information from the experimental design or the results, explain why Ava's hypothesis may be incorrect. So even though energy drinkers did read about, 1.5 seconds faster? Let me do 19.1 minus 17.7, 1.4 seconds faster. It may be because the better readers from the start were coincidentally put in the energy group, the energy drink group, I should say. Okay, so using the given results, Ava randomly mixes the 20 reading times, splits them into two groups, and simulates the difference of the means 232 times. So here's where we run the simulation, and we just kind of keep splitting all these 20 up into 10 and 10 randomly, 10 and 10 randomly, and we kind of see what the mean differences are. In your graph, they do say group 1 minus group 2. So our group 1 minus group 2 number is negative 1.4. So we got negative 1.4 is our actual observed difference. So on our graph, negative 1.4 would be somewhere in here. Okay. So negative 1.4. So coincidentally, this many times, that difference was due to just kind of the way they were grouped as opposed to the actual drink that they were drinking. So out of 232 times, how many simulations is this? Well, I'll check the height of each of these bar graphs. There's 3. There's 2, 1, 2, 3, 2, 2. 5 times 1, 1, 2, 1. So if I add all those up, 5, 6, 7, 8, 11, 13, 15, 20, 21, 22, 23, 24, 25. So 25 out of 232 simulations resulted in a difference as drastic as negative 1.4. And because these were the simulations, that happened by coincidence, definitely in those 25 cases. So essentially 25 out of 232 means that approximately 10.8% of the time this happened by coincidence. A coincidence of how the kids were grouped. But on the flip side, that means that 89.2% of the time, there's an 89.2% chance that this difference was actually due to the drink. So even though this could have been a coincidence, it's still more likely than not that it was caused by the drink. Ava has decided that the difference in mean reading times is not an unusual occurrence. Support her decision. So she's going to go with this one. she's kind of, that would favor the other person's, oops, I'm sorry. She's going with this one. This kind of way of spinning it would favor the other person's thought process. So she's saying that 10.8% of the time happening by chance means it's not that unusual. I mean, it could have been luck. So you would say something like what we already wrote, but since 25 out of 232 simulations resulted in a difference as drastic as negative 1.4 by coincidence, that means that approximately 10.8% of the time this happened by coincidence of how the kids were grouped. And just say, therefore, it wouldn't be overly unusual. For this difference to have happened by chance due to sampling variability or the random assignment variability. Okay, so that is all for that test.